When wishing in Genshin, it's pretty common to know about the soft pity and hard pity, but what is the average pity for each of the banners? Hello, Sacke here, back with another Genshin Impact video. Today, we'll be diving into some statistics to ultimately figure out what the average pity should be. To get things right off the bat, the average is about 60 on the limited time character banners, 51 for the limited time weapon banners, and 54 for the Wanderlust Invocation banner. But hold on, don't those seem a little low? Also, where did I get those numbers? Is the data I used even trustworthy? And do these averages even matter? These are questions I hope to answer in this video, and I'll give some word of advice regarding to what this means for your wishes. If you can't trust data, can you be confident in any conclusions drawn from it? Obviously, no. If the data doesn't accurately represent the system you're analyzing, you can't make any trustworthy conclusions about the system. This is why I'm outlining this section. KokomiClan, in a video talking about the Chinese Spiral Abyss 3.1 usage rates, outlined 4 criteria to get a feel for how trustworthy data can be. 1. The sample size is large and is a good representation of the population. 2. The data is obtained independently and in an identical manner. 3. The data was collected within an appropriate time frame. And 4. The data makes sense with known values and models. So, what the heck does that all mean? Let's take a look at the first criteria. The sample size is large and is a good representation of the population. First off, population and sample are statistical terms for systems. A population is the actual and entire system being considered. What we try to do in statistics is determine things about the population. However, collecting data from everything in the population is often unrealistic to achieve. Sometimes the population is literally infinitely large. Instead, what people do is take a portion of the population, call it the sample, and make estimates based on that portion. A simple way to visually understand this is with shapes. This larger white shape is the population. A sample would be this cut out smaller piece of the population. However, notice that we can have a large cut of the population, but it doesn't look similar to it. What we want is that the portion looks similar to it. This sample, while smaller, does look like it more accurately represents the population. In general, if we have a larger sample size, it is reasonable to say that it's more likely to accurately represent the population. Notice that if I were to increase the sample size of B, it would have to conform to the shape of the population. This is what the first criteria refers to, whether or not the sample size is large enough to which we can confidently say that it can accurately represent the population. For the second one, the data is obtained independently and in an identical manner. This is a matter of how the data is collected. In our data, we want to make sure that there is no unintended interference or influence on one piece of data over another. This is what we mean by independent. If data has dependencies outside of what we expect, we get different results, and this is why we want it to be independent. We also want to make sure that each sample of data is obtained in the same way. Changing how you do something changes the result, and that's the same for data collection. This is why we have very detailed instructions for methodology and how we collect data. Third, the data was collected within an appropriate time frame. I do hope this one is relatively self-explanatory. Sometimes, time is a factor that influences the data, which might not always be the case, but it's still important to note. If time matters, then that means the data is dependent on it. Another thing is that maybe certain events influence the data, so timing is also important. Lastly, the data makes sense with known models and values. This is more like a gut check. Typically, there are some things known about the population. If the data shows these aspects, then we can be relatively confident the sample does resemble the population. Hopefully now we can understand these criteria. Let's take a look at our data. The data that we'll be analyzing is taken from Genshin Wishes, which is a website made by Colin Allberger and Jimmy Vergerol. Players can volunteer to use the service to store and track their wishing data, while also seeing various statistics for free. It collects the data by looking at the player's in-game wish history. Unfortunately, Genshin Wishes has shut down their services, but luckily for us, the data we're interested in is publicly available on the website. it has data from version 1.0 to 2.7. I'll leave a link to the website in the description if you want to look around it. First question: is the sample size large enough? The data we're interested in is the total number of roles on each banner. It doesn't matter which characters or weapons are featured on the banner, so our sample size is based on the total number of wishes recorded. Genshin Wishes has data containing 98,237,919 wishes for the character banners, 20,841,514 wishes for the weapon banners, and 38,164,312 wishes on the Wanderlust Invocation banner. I think it's pretty safe to say that we have a large enough sample size for all of the banners. Second question: is the sample data representative of the population? Genshin Wishes states that it has data collected from a total of 345,488 players, with a relatively even split amongst the Asia, America, and European servers. Do note, though, that this does not have data for the Taiwan, Hong Kong, and Macau servers. However, I don't think that should make much of a difference, as I doubt the banner rates change from region to region. Third, is the data collected independently and in an identical manner? I mentioned earlier that Genshin Wishes collects their data by looking at your in-game wish history, so it is collected in an identical manner. Let's think about the independent one. In the FAQ, it states that they get your wish history by using a temporary key available for only 24 hours. You personally have to get this key by prompting your computer and giving that key to Genshin Wishes, and as far as I can tell, this makes it independent. Is the data collected within an appropriate time frame? Yes, the player's wish, the date and time when the player wishes, is stored by HoYoverse themselves, which can be viewed in the wish history, and yeah, you also have the option to view the data per banner, which is also more evidence to show that it has an appropriate time frame, but we're not interested in each individual banner. For the last criteria, does the data make sense with known models and values? Yes. I could explain it here, but I feel like that requires its own section, so I'll leave it as an appendix. You can take a look at the chapters if you want to see the justification for this one. But in short, yes, you can trust Genshin Wishes data. The data that we need to get is how many people pulled a 5-star at a specific pity for the limited time character banners, the limited time weapon banners, and the Wanderlust Invocation banner. For the character banners, we can navigate to Global Stats, then click on Character Event Banner Stats. Make sure the drop-down is on all events. We can then scroll down to the 5-star quantity by pull number graph and hover our cursor over each individual bar. What we see is the pity number, and under it is the number of times a player pulled at that pity. In a spreadsheet, I've written down all of these numbers. We hover over all of these bars until we reach the end. We can repeat this for the weapon and Wanderlust Invocation banners. Now, I did have to guess some values at the highest pities to make it consistent with the given 5-star counts. However, whether I include these guessed values or not makes barely any difference, as the number of people who pulled very close to hard pity is a very small number compared to all the others. For reference, the difference in magnitude is at most tens compared to thousands. That's a very huge difference, so again, it probably doesn't make much of, if any, a difference at all. Let's now head on to a statistics lesson. Average is the more common term that people tend to use in daily life. However, in statistics, we use the term expected value. Expected value and average are the same thing. They are a value that the data tends to skew towards. When people think of calculating average, they usually think of this equation. X bar is equal to the sum of all samples divided by the number of samples. However, this equation isn't actually going to be very useful for our case and can only be applied in certain scenarios. The actual equation of the average or expected value is the following. E of x is equal to x times the probability of x summed over all possible values of x. E of x is the expected value of x. X is some sort of sequence of events or a representation of one. X sub s is the set of all possible values x can be, And lastly, P of x is equal to x is the probability mass function or probability distribution. It's kinda hard to explain what a probability distribution is, but I believe I do a better job of explaining it in the appendix, so you can take a look at it later. In the case of the data that we're examining, x is the pity a 5-star was pulled, E of x given g becomes the expected pity at which you pull a 5-star. S is the set of all possible pities we can have on a banner, so it's the set of integers from 1 to hard pity, which I'll represent as h. This makes P of x is equal to x given g the probability that at x pity you pull a 5-star. G just means that we pulled a 5-star. However, you might notice that we don't have the probabilities, we have the number of times a 5-star is pulled at x pity. Solving this problem is actually quite simple. I'll define y sub x as the number of times a 5-star was pulled at x pity, and n, the sample count, as the total number of times a 5-star was pulled. This means that we have the following equations. Another thing that I'd like to calculate is something called the standard deviation. This is a measure of how much each data point varies from each other. The higher the number is, the more the data points differ from each other. We take the square root of a quantity called the variance, and the variance is defined as the following. And if we simplify it, it actually comes out to this. In our case, we're calculating the variance in the pities that players got 5-stars at, so v of x actually should be v of x given g. Lastly, the sample standard deviation is defined as the square root of the variance, so yeah. Implementing these equations into the spreadsheet, we ultimately find the following expected pities that you'll pull a 5-star. Based on these results, the banner where you're more likely to get a 5-star at lower pity is the limited time weapon banner. This makes sense as the hard pity for it is the lowest at 80 and the base pity for the weapon banner is 0.7%, which is higher than the 0.6 the character banner and Wanderlust invocation banners offer. The character and Wanderlust invocation banner appears to show that you're more likely to get a 5-star at around 60 pity and 54 pity rounded up respectively. That the difference despite having practically the same base rate and hard pity could be because the number of samples for the Wanderlust invocation banner is not nearly as large as the character banners. Keep in mind that it also does have the highest standard deviation, so that means it has the largest variation in the pities at which people pulled 5-stars. This is a very important message to all of you. The averages that I stated honestly are quite misleading. When I say that the average pity that you'll get a 5-star at is 60, you probably thought that most of your pulls should be close to 60. That's not necessarily true, and in fact, you probably can just observe that from your own pulls. I would say that there's a better way to interpret the Genshin Wishes data, and that would be through these quantities. 1. The probability of getting below soft pity knowing you pulled a 5-star, and the probability of being at or above soft pity knowing you pulled a 5-star. We can calculate these conditional probabilities through these equations. And the values can be shown in the table below. The limited time banners seem to have roughly the same chances, with about a 40% chance that you'll get a 5-star before soft pity, and a 60% chance you'll get once you hit soft pity. For the Wanderlust invocation banner, there's about a 50-50 even split between pulling before and at or after soft pity. Personally, I find the Wanderlust invocation's chances of pulling a 5-star before soft pity hard to believe, but I'll leave that judgment up to you. What I like about these values is that it tells me, on average, about 40% of my limited time 5-star characters should be pulled below soft pity, while 60% should be at or above it. If we look at my own data, it is actually relatively close considering that I only have 14 samples on the limited time character banner. I seem to be very unlucky for the Wanderlust Invocation banner, so I don't think I can compare it, and I also have never rolled on the weapon banner, so yeah. So if there was a quantity that you should keep in mind when rolling, it should probably have to be these: the probability of pulling a 5-star before Soft Pity versus the probability of pulling a 5-star at or above Soft Pity. Most people, when they think about average, unconsciously think that the probability distribution is what is called a normal distribution. A normal distribution basically assumes that most of the data is evenly spread around the average. However, that is not at all true for Genshin Wishing. Just looking at the distribution, we can clearly see that most of the data is actually more towards the end, which is actually expected, again, based on your own experiences with Wishing. You shouldn't expect most of your character banner rolls to be around 60. In reality, you should be expecting that your 60% of your limited time 5-star character pools will occur at least 74 pity. If you're wondering, the reason why the average is pulled down below Soft Pity is because there's a fairly sizable amount of players who have managed to pull below Soft Pity. This brings down the average down by quite a fair margin, so yeah, that's easily explainable. For the sense check, this part is rather technical and might not be the most comprehensive as it requires background in statistics, though I'll try to be clear and make it understandable. Anyway, let's do it for the limited time character banners. There are only 2 events that we need to consider: got a 5-star or didn't get a 5-star. Technically, we could do got a 5-star, got a 4-star, and got a 3-star, but for this case, we're only really interested in 5 stars. In the case of Genshin, we start at 0 pity, and when we wish, either we don't get a 5-star or we do. If we get a 5-star, pity resets back to 0. So essentially, we fail to pull a 5-star on a certain number of times in a row, then pull 1. As mentioned in Genshin Impact's Wish details, the base probability of getting a 5-star is 0.6%. However, there is a caveat to this statement. As we all know, there's soft and hard pity. The existence of soft and hard pity makes things a lot more complicated in terms of the math. In statistics, there's this thing called independence. This basically means that 2 events don't influence each other's probabilities. However, if 2 events do influence each other, they aren't independent, and we have to deal with conditional probabilities. Your chances of getting a 5-star are clearly dependent on what your pity is, so yeah. This is evident given the fact that starting at soft pity, you get 5 stars more frequently. The probability of A given B occurs is the following equation. PA, B is the probability both A and B occur, and P of B is the probability B occurs. When A and B are independent, the probability of A and B is equal to the probability of A times the probability of B. So, the probability of A given B is equal to P of A times P of B divided by P of B, provided that A and B are independent, and then the probability of A given B is equal to the probability of A, given that A and B are independent. You can interpret the probability of A given B as the probability A occurs if the situation is B. This is where the conditional part of the probability comes from. Going back to Genshin, I'll define X as the pity. Therefore, we now have a general expression for the probability you pull a 5-star at X pity. P of G given X is equal to X. In a HoYoLAB post by the user Sengalev, they gave equations for this conditional probability, which are the following. And here are some statistical identities to note of. The data that we analyzed earlier is what we call a conditional joint probability mass function or a conditional probability distribution. Since we have to deal with conditional probabilities, the probability distribution is actually P of x is equal to x given g. Putting that into English, P of x is equal to x given g is the probability that you're at x pity given that you pulled a 5-star. I want to emphasize the difference between the probability x is equal to x given g and the probability of g given x is equal to x. The probability of g given that x is equal to x is the probability that you pull a 5-star at x pity. The probability that x is equal to x given g is the probability that at x pity you happen to pull a 5-star. They sound similar, and honestly, if I ask these questions, what is the probability you pull a 5-star at x pity versus what is the probability that you're at x pity when you pull a 5-star, they practically sound the same, and I wouldn't blame you. To distinguish between the two quantities in questions, we need to understand what each value is looking for. For the probability of g given x, you're uncertain about your chances of getting a 5-star. But for the probability of x given g, you're uncertain about which pity you'll pull a 5-star at. Imagine that you told someone you pulled a 5-star at 50 pity. Since 50 pity is under soft pity, we know that your chances of pulling a 5-star at 50 pity is 0.6%. Let's now change the situation. Let's say that someone pulled a 5-star, but you want to know what are their chances that the person could have pulled at 50 pity. This is the probability x is equal to 50 given that they pulled a 5-star. Notice that the Genshin wishes data is basically that. It is given that the data points are from those who pulled 5-stars. I calculated the probability that when you're at 50 pity you pull a 5-star is approximately 0.4%. For another example, you could say that if someone pulled a 5-star without telling what pity they got it, you'd probably guess that they're more likely to pull the 5-star past soft pity. This is a mental guess calculating the probability that your pity given that they pulled a 5-star. If someone asks how likely it is for you to pull a 5-star and you think about a small chance, what you thought about is the probability of pulling a 5-star at x pity. It really takes some thinking to distinguish between the two, but focusing on what is unknown and what is being asked for can really help you tell the difference. Genshin's wishing system follows a geometric distribution. This is basically a probability distribution where there are only two possible events, often denoted as failure or success. And either of those two events occur a certain number of times. Each time one of the events occurs is referred to as a trial. Typically, we're interested in examining the number of failures that occur before obtaining a success. For our case, the number of trials is represented by our pity. A failure is when we don't pull a 5-star, and a success is when we manage to pull a 5-star. Since we're dealing with conditional probabilities, our probability distribution is the following. Note that this distribution must satisfy the following statement. And it does. X sub s is just the set of all possible pities for a banner. Putting these equations into decimals shows that it does work. This restriction along with soft and hard pity gives a theoretical distribution which would look something like this. Notice that this actually does look a lot like the distribution shown from Genshin Wishes. We expect the probability distribution to start off at about 0.6%, then slowly decrease until we hit soft pity, and then the distribution shoots upward, peaks, then goes back down to 0 by 90 pity. We have this large spike in the distribution because Hoyoverse added a hard pity, and even a soft pity. What's interesting is that, based on this theoretical model for the wishing system, the average pity you pull a 5-star at should be about 63, where your chances of being at a pity lower than soft pity when you pull a 5-star is about 35%, and the probability that at soft pity or above you pull a 5-star is about 65%. Based on the actual data gathered by Genshin Wishes, the actual system might be a little bit more generous. or it's just a byproduct of randomness, or it could be that Sengalev just assumed a less generous model. If they stuck with the 0.6% base probability until hard pity, you actually wouldn't be guaranteed a 5-star at 90 pity. In fact, it would only be about a 40% chance that you get one by 90. Obviously, HoYoVerse doesn't want to lie about the hard pity, so they need to add probabilities elsewhere. They actually could have chosen to force you to go to hard pity every time, but what they did was decide to increase the probability of getting a 5-star starting at soft pity. Genshin Wish's data checks out with the details given by HoYoVerse in-game, and it checks out what we expect from a geometric distribution. Something I would like to point out, the reason why the distribution decreases from 1 to soft pity despite the probability of pulling a 5-star remaining constant is because if you successfully pull a 5-star at 1 pity, you immediately go back to 0 pity. This means that a smaller portion of players gets to move on to 2 pity, then a smaller one for 3 pity, and so on. You can think of it like this. If you pulled a 5-star at 35 pity, you don't go on to 36 pity and beyond. You go back to 0. So you hit 35 pity more frequently. In conclusion, these are the average pities that you'll pull a 5-star at. But I personally find these values are rather misleading. I personally recommend that if you're trying to get a better idea of which pity you'll pull a 5-star at, consider the probability of pulling a 5-star below soft pity and the probability of pulling a 5-star at or above soft pity. These quantities are shown in this table. Anyway, I hope all of you got to enjoy this video and got some useful ideas about what to expect when wishing. If you're wondering, this thumbnail I used for my Shenhe summoning video actually references the theoretical probability I'm at 9 pity when I pull her. Just a fun little trivia, you know? So yeah, that's really about it for now, so thanks for watching and hope you've enjoyed.